So if any of you have issues with privacy issues, you'll have to sign off. Okay, and then I can share you the recorded videos. Else your names might just show up. Okay, that's the only thing. Because many other students might benefit from a solution discussion of 2023 paper. Okay, so let's I don't know when I mark this. So probably we discussed, I suppose, aptitude and math earlier on this, I suppose. So there I wrote one of the easiest. Okay, appears to be my comment written long time back. So this is GATE Biomedical 2023 paper, right? Yeah, GATE BM 2023. Yeah, biomedical engineering. Let's get. I think even this much. GATE. Let's see. The font is better. This looks slightly better. So this is 2023. So most of you tried this test today morning. How was the paper? Can we have a quick, let's do a quick review and then we'll start solving this. How was the paper? Let everyone know that they are being recorded. Yeah, I already made the disclaimer. Being recorded. How was the paper? You may not have got your scores and all that. This is the GATE interface, right? But still, you would have some impression on how it was. Okay, good. One of the feedbacks, good compared to the mocks. Okay, yes, mocks I usually try to make some questions really hard, if not all questions. Most questions GATE level. Okay, moderate. So I'm hoping that your performance is good compared to other mocks. Okay, they're not really concerned about whether the question paper is good or not. They're concerned about your performance. I'm hoping that the performance is good compared to this one. And also, so we are going to start discussing the solutions, right? So I have like 2-3 pages of rough work done, which I did today morning. Okay, and to give a context, we have to be clear on how much preparation went on, that takes to solve this and all that, right? So that students appreciate the amount of work that goes behind this. So probably we discussed GA and math before this, right? So rest of the question paper, actually, I didn't see that question paper. I skimmed through it. The 2-3 minutes skimming I suggest, the beginning of the exam. I did that. Other than that, I really did not look at the questions in detail. Okay. So this, I think we have seen and solved it once. The rest, roughly, 75 marks, I suppose. This is like 10, 20. So roughly 75 to 80 marks I haven't really seen. Okay, until today morning. And for convenience, I have also marked the official answer key here for all the questions. Oh, this is actually, this is a GA amplitude and things like that we have already discussed. See, it's already there, but fine, yeah, let it be there. So I haven't seen the rest of the questions. I have marked all the answer keys for convenience. Okay. What I thought as I could do about 96 plus out of 100, probably 98, 97, 98 out of 100. Okay. I don't revise and practice like prepare like students, but I have been teaching this for like 4 years, right? So students give first attempt, second attempt, some students give third attempt and all that. By then also it kind of gets really strenuous, right? Third attempts is like very, very strenuous. So I have been doing this for 4 years now. 2020, 2021, 2022, 20, so this is a 2023 paper. Now for you, 2024 paper, right? So that much amount of work has gone behind preparing for that. Preparing things in the syllabus, especially from a teaching perspective. Okay. So in fact, to empathize with some of the other teachers, the work that the teachers do, or if you have to do it for 1 year, 2 year, they have to do it for 10 year, 20 years and all that, right? In that way, we should appreciate what the rest of the teachers are doing. So 4+ years of experience on this, plus I'm not mentioning the rest of the other things, rest of my other qualifications and things like that. But I don't prepare, revise, recall formula and all that like a typical GATE student does. So I did make, I did take some help from Wikipedia, okay, for about 5 questions or something like that. So if you ask me to give this test and how much would I score, okay, without any preparation, just by what is going on, uh, you know only preparation that is needed for teaching the class, to only keep that, okay, that is I don't spend time remembering, recalling formula and all that, I'm expecting to get around 75 out of 100. This is zero GATE preparation as a student, as a participant. If I prepare, spend some amount of time recalling, revising the formula and all that, probably this is around 85 out of 100. Okay. Some, if I am really desperate, okay, which some students are, I am not in a position to be really desperate about GATE. But if I am really desperate, where I prepare known things, recall, revise known things, practice, as well as I learn some things that I do not know of, okay, which is where I would expect 90+ out of 100. This is accounting for some of the possible silly mistakes, accuracy and all that, right? I might know it, but I might make some silly mistakes in the exam and all that. So 90+. So with Wikipedia's help, I am over here. Wiki's help, not for all questions, but about 5 questions are like that, I did take help with Wiki's help. So this is to give you a perspective from my side. Is a very honest perspective. You wouldn't really hear from a teacher how much they know, how much they don't know. No. It is a just to uh, put things in perspective. Okay, that's why I shared this detail. And what I am really hoping for is that some of you, if not most of you, even some of you, those who are listening or watching this video later, not the live video, perhaps a recorded video, you get here, okay, and start putting a very good fight compared to other branches in GATE exam, electronics, mechanical, civil, and all that. Compared to that, it would be really nice if BM paper All India rank 1 is scoring above 70, 75, 80, 85 and all that. That is my sincere wish to all of you. Okay, those who are here as well as those who are watching. And this is my perspective. So in fact, I don't know when I wrote this, but I will I mentioned this about GA aptitude and math. But after going through this today morning, I went through this about about 2 hours. Okay, I thought it might take about you should sometimes 2021 paper and all that I have taken a day or two to answer, perhaps a whole day or even a little more than a whole day. But in about 2 hours or something like that, I could kind of like solve most of this. in 2 hours I was in like this 80 plus range, 80, 85 plus range. Okay. So this still holds good. This is one of the easiest papers. Okay. Perhaps if 2022 is the most easiest, this comes second. Okay. In terms of easiness. Okay. That's my thing. So, quick, um, how much do you expect to get? You wouldn't have got a score in the gate interface and all that, but how much, what are we seeing from the other side? 40s, 50s, 60s, 70s, roughly? Does anyone know what the All India rank 1 score on this paper? Then this should be, okay. So some of you are saying, 40 to 50, 50 plus, 50 plus, Vigneshwaran around 60, 60 plus, I suppose. Some of you, I'm just going based on past, past performance. It's indicative, that's it. All India rank exactly 60 or around 60? Okay. So I suppose these are exact numbers. All India rank 1 scored 60 out of 100. All India rank 2 scored 52 out of 100. Okay. Yeah, that's slightly disheartening. My wish is that, this has been my wish pretty much for every year, that biomedical students should put up a real good fight, uh, you know, among their peers, which are students from other branches, right? Specifically in the gate exam. So, this would be a nice target. The paper is easy like this, 70, 75, some of you, okay. This would be a nice target. 60 plus, 50 plus, you're probably in the single digit All India rank. Okay, so now let's start solving. I cannot support this proposal. So some of these are pretty obvious. And before even we start, one thing that I don't want to do at this stage is to not try to explain a concept that happens in class, not at this stage. Okay, so at this stage I don't want to confuse you. You don't know some question, you don't know, forget it. Okay, so I'm going to try to avoid explanations, why or something like that and all that, totally new concept and all that, but still we will certainly think and discuss strategies, approaches and all that for interesting questions. Okay, for obvious questions we'll just make a mark and move on as fast as possible. Probably this will take about 2 hours, 2.5 hours. Okay, and for some numericals I might give about 2 minutes or so for the calculation step. Okay, so this might help you to see how fast you're able to do things and all that. And one more important thing, let's do 2 passes. First pass, question so easy questions, most of you could do it, let's do it. Okay, second pass appears hard, might be easy, hard, totally untouchable, different story, but appears hard, we'll do it at a second pass. Okay, the continuity is lost, but this is what I suggest you do in the actual exam. Get as much marks and gain as much momentum as possible by solving the easy questions first, and then look at what appears to be hard or doesn't make sense, right? So let's do 2 passes. First pass, I cannot support this proposal. My will not permit conscious conscience, right? I think this is pretty obvious. Consensus, consent, conscience. Okay. My conscience will not permit. The sentence sounds much better than rest of the other sentences. Even if you are slightly lost on the meaning of all this. Right? Okay. Courts dash parliament legislature. So can we make quick short sentences here? Quotes legislature. Probably we are looking for a noun, right? Executive, governmental, legal. Probably there it kind of points out it's judiciary. Something like that. Courts pass judiciary, okay, or parliament passes legislature, something like that, or legislature. So is pass like the connecting word between these two, subject, object, verb. Pass as in pass a judgment, like that is good. As courts pass judiciary, or courts follow judiciary, parliament follows legislature. Pass or follows, either one of the word kind of it's it. Okay. So this is judiciary. Fine. What is the smallest number with distinct digits whose digits add up to 45? You made the counts here. So all this add up to 45, all this add up to 45, all this add up to 45. This doesn't add up to 45. And the smallest one here, obviously, is this, right? Again, no issues there. So expected, this is almost expected everywhere. One question based on numerical, based on set theory, and one logical question based on Venn diagram. Almost expected every year. So there are a class of 100 students, so total 100. 30 students who neither like romantic movies or not comedies. Okay. So those who like both R and C will be 100 minus 30, that is 70. So this area over here, that probably is 70. And then number of students who like romantic movies is twice the number of students who like comedy movies. So R is romantic movies, comedy movies. So NR is 2NC. And then, yeah, this union is 70, which you can also write it as NR, NC, and the intersection. Right? So from this, can you fill up some intermediaries? I suppose these steps are correct, right? I suppose you get 3NC is 90. So can we fill up the details from here? So the union happens to be 70. Do we know, okay, this is 3NC. This is also given. The intersection is 20. So yeah, this is 20. And, this happens to be 70. So 3NC is 90. And then NC is 30. 2NC will be 60. Very simple. Okay, count the number of rectangles. Only suggestion, be systematic. For example, small rectangle, so square is also a rectangle by definition. Okay, defined based on angles. So small rectangles, this rectangle, so small rectangles, you have 4. This rectangles you have like again 4, and then probably you have the big rectangles. So there are 2 of them. So totally 10. Fairly easy. Sometimes number of triangles is also fairly easy. Be careful. Again, they ask for number of triangles. Count the small triangles, and then medium-sized triangles. Okay, and then big triangles, 4 of them. Okay, be systematic in how you do that. Yeah, there is typically one Venn diagram based questions, and forest land. Let's explain this Venn diagram again. So notice logically inferred technically means with certainty. Okay, but they are being explicit. Logically inferred with certainty. Okay, fine. Forest land. Okay, there is a forest inhabited by different creatures. Among other creatures, it is populated by animals. So within forest we have creatures, and within creatures we have animals, and then there are also creatures that have claws and some do not. Yeah, in the set of creatures, some of them have claws, and all creatures that have claws are ferocious. Yeah, notice the clawed creatures is a subset of ferocious creatures. Based on only this information provided, what can you logically infer with certainty? All clear creatures with claws are animals. You know, the claws that is over here. Some creatures with claws are non-ferocious. Some, notice at this stage, this logical question usually is a bit tiring. So my suggestion is always do this at the second pass. Okay, but we are kind of halfway in, and it will take a minute or so to finish it. So let's just finish this. Okay, you need that mind to be fresh at the beginning of the exam. Typically, you know, do it at the second pass. Okay, but we already, you know, ruled this one out. Some creatures with claws are non-ferocious. Yeah, there is this region. Some creatures with claws are non-ferocious, right? There exists a set between this orange and this blue. Let's also kind of differentiate this. Okay, there is that set. And then some non-ferocious creatures have claws. About this statement, is this statement correct? At least based on the Venn diagram I have drawn, seems to be correct, right? Some non-ferocious creatures have claws. Okay, somewhere all creatures that have claws are ferocious. So probably then this Venn diagram, there is a mistake there, I suppose. Yeah, see, this is exactly the point that I was reveling on anyway. So the statement kind of contradicts with the statement. At this stage, may or may not be. Yeah, fine. You know, this has to be done at the second pass. Okay. This is kind of expected. We'll get back to this. So let's start marking things question. Let's do this question at the second pass. If you're spending any more time, any more energy at this stage, it's a big mistake. Your fresh mind, you're putting a break on that. This very logical thinking is very tiring. You don't want to happen at this stage, okay? And these 2 marks are not worth it. But we'll come back and solve it, okay? Okay, which one of the following options represent the given graph? So even or odd question again, this is typically always, you know, this shows up. There is every year almost there is one question from this even odd. You know, this has this symmetry, and this is an even function. F of x is f of minus x, right? So notice f of x at any x, that value, you know, at minus x is also the same value. So this has this even symmetry, and the points are very easy to see. Notice this is an even function, this is an even function. Product is an even, so this is a possibility. This is an odd function, this is an even function. Okay, this has to be odd into even, has to be odd, so you can rule this one out. This is an odd function, this is odd, or you know, this is not an even function. You put minus x, it's different. Okay, So probably this is an even function. Again, the product is either odd or neither. It's certainly not even. Okay, again you can rule this one out. So now this is odd. This 2 power minus x can be, it's not odd, but let's say has like odd characteristics. Odd into odd can technically be an even function. If it were odd, it can be an even function, but I don't think this is odd. But so how do we quickly decide between A or D? We have to look at some other aspects. So 0 is always, f of 0, quickly look for special cases. 0, fine. What happens at 1 or something like that, maxima, or what happens at the extremes. Okay, mod x e power minus mod x decays symmetrically. So the product with x square again is exponential. This is just a polynomial. So the product, this exponential will dominate. Towards infinity, this decays. 2 power minus x, on the other hand, doesn't decay, at least on one side. Okay, so at infinity, this function will not go to 0. This function will go to 0. So based on that, we make this. What happens to the function at infinity? Okay, and then we also asked, okay, what is it, even or odd? Notice this is not necessarily odd. It's odd like 2 power minus x is need not be symmetric about a particular axis, but it has like odd like characteristic. Okay, it has a minus x term, so the that symmetry is kind of lost, which is what I'm trying to say here. Okay, comprehension fairly easy. Which one of the following options can be inferred from the plastic? When I was a kid, so probably an adult is talking, I was partial to some students, right? Okay, so they had a special inclination to stories of other worlds, interplanetary travel. You just imagine gaze off into space, this to another planet. Child's description of what he or she likes, fair, but it's more specific, right? It's an adult's memory of what. Yeah, it's not a child's description. It's an adult's memory description. What or she liked as a child. This makes sense. Child in the passage read stories about internet travel only in parts. Oh, this probably they are trying to confuse you with this partial with this part. No, partial we know means part inclined towards one side, liking towards one side. So this is not the case. It teaches us that stories are good for children. It's a vague generalization, not specific to this statement. So I suppose this is option B. Okay, out of 100 individuals, 100 unidentified individuals are COVID positive. Okay, you want to do what is called this group testing. So testing groups of 5. If a group is positive, test each of them individually. The group is negative, keep all those 5 aside. So out of 1,000 people, you're going to test 200 samples. What is the worst case scenario? I suppose each positive person is in a different group. That's a worst case scenario. So you have 100 positives in the worst case. Okay, 100 negative. It is the worst case. Okay, and then this 100 negatives you will have to do. And here, so each this 100 you'll have to do separately, right? 100 has technically 500 people. You have to test them individually. Okay, so by that I suppose this 500 and this 200 tests will be 700. So answer to this question is 700. But this enforces this nice idea called group testing. And notice at this stage we can be fractal or recursive. So this 500 people, again, we can split it into 5, right? So the max number of tests we can do need not be 700, 600 and all that. We can bring it down drastically. Log of 1000. Okay. We can bring it down drastically. So this 500 again suffices to one more 100 tests, and then with that 100 worst case scenario, okay, you can think of it. But the given question answer is 700. Fine. 100 centimeter by 30 centimeter. The sheet is folded 5 times. Each time the sheet is folded, long edge aligns with the opposite side. Which is a long edge? 100 centimeter. One thing that makes this question fairly easy. Each time the sheet is folded, long edge doesn't change. If it changes, kinds of behave, this is the long edge, this is the long edge. They can set up a nice trap there, but here they haven't set the trap. Long edge remains the same. That drastically simplifies this question. Okay, if I had to set a trap, that's where I would set. Okay, remains the same. Eventually, the folded sheet is a rectangle of dimensions 100 centimeter by 1 centimeter. So probably, yeah, 32 side became 16. That first fold. Let's write the lens in blue. You have 16. Now fold number here. First fold, second fold, third fold, fourth fold, fifth fold. By fifth fold, you are like 1 centimeter by 1 centimeter, and you are this thick, right? So at each multiple of 1, you have a fold, right? And totally we'll have from 1 to 31, because 31 is the end of the paper. So we have 1 to 30. This is fairly easy. Can be made hard if the long side changes. Okay, but this question is fairly easy. Fine. We have some tips here. These are discussed outside. Perhaps I can give some tips at the end of this discussion. Head on to this. What is the magnitude and the difference of the mean and the median? Mean would be sum of all this by 6. Okay, quickly 24 by 6. That is 4. Median is a arrange them. Things are already in a sorted order. The central element, the even number of terms, so somewhere in between. Average of these two, 3 and 4, that is 3.5. Difference between them is 0.5. For a binomial random variable x, e of x, where of x, what is the expectation and variance respectively? Which of the following statements cannot be true? Yeah, you will have to recall for a binomial random variable. Mean is NP, that P is probability of success. Variance is NPQ. Okay. Idea is Q is a number less than 1. P is also a number less than 1, but compared to NP, this is being multiplied by a fractional number Q, that is between 0 to 1, probability of failure. So this term is a small fraction of NP. Okay, so in fact, I have to write the order other way around, I suppose. NP is a bigger number. NP has to be a bigger number. Yeah, I don't know why none of you pointed the NP has to be a bigger number. So let's quickly see. NP is a bigger number. NP is a bigger number. NP is a bigger number. Hey, NP is a smaller number. No, this has to be a variance, has to be a fraction of 10. Anything less than 10 kind of makes sense. This order is incorrect, right? What I had there. So this is where having recalling ability to quickly recall properties of standard distributions, that kind of help. So again, we have discussed this. Let's move on. Let's give this a couple of maximum minute or so. I'm writing too many commands, right? So in that case, it gets slowed down. Okay. Q is this 2 by 2 matrix. Which one of the following statements is true? Q is equal to the transpose. We can say it is not. Q is equal to its inverse. 2 by 2 matrix has a simple inverse formula. What is the determinant here? Determinant is phi, I suppose. What is the determinant? Phi. Determinant is phi. So this is 1 over phi. Yeah, 1 over phi term is missing, right? You're already off by a factor of phi, so you know this is not the inverse. Q is a full rank, or can you write one column in terms of the other column or one row in terms of the other row? No way here. Okay, they are independent, so it's full rank. Q has linearly dependent columns. No. So any other row here, that is x times 1, x times 2. X is any number, any real number that would have made it dependent on the this column. If it were 1 times x and 2x, it's just a multiple of the first column, right? So we have discussed this. So in that case, it would be dependent. In this case, it's independent, and hence it's full rank. Which one of the following vectors is an eigenvector corresponding to the eigenvalue of matrix? Matrix A is this. Many differential equation questions in math, partial differential equations, algebra, eigenvectors, eigenvalues, we can often verify, right? Just plug in these numbers. I suppose if you combine, okay, give zero weightage, zero weightage to this column, zero weightage to this column, only take this column, you are going to get back that column, right? So we have that. So by definition, that's the eigenvalue, which is what I think I have explained here. So this is option D. And verify it, okay? AX has to be lambda x. Lambda is 1, I suppose. Yeah, lambda is 1. Let's move on. Partial derivatives. Okay, so f of x is e power x cos x. First partial with y, this is only partial of this is minus sine y. Take partial of this, only e power x matters, e power x remains e power x. So plug in 0 on pi by 2. Pi by 2, this is 1. At 0, this is 1. So you have minus 1. Okay. See, I put up this playlist, basics of biomedical signal processing, where I explain actually a short playlist, 5-10 minute videos, about 20 videos or something like that. If you had actually seen that playlist, you could have answered about many of the electrical circuit questions that I've shown up here. Okay, this is fairly easy. Choose the angular frequency omega naught at which the voltage across the capacitor has maximum amplitude. When is voltage across the capacitor maximum? Can anyone give a concise answer? XC max. Fine. When does that happens? Okay, I agree with Amar sir. XC has to be maximum. XC is maximum. Omega is 0. XC tends to infinity. Fine. Any other answers? A 1 by RC. No. This is like think about it. Because the same question is repeated, they're going to ask about one more frequency. Probably there 1 by RC is the magic frequency that you're going by. Okay. But unfortunately, here they are not referring to the magic frequency. That will help you with one more question down the line. Okay. So Amar is kind of like getting pretty much all the concise answers, multiple answers. This will open circuit at DC, at which point this will have maximum voltage. The voltage essentially that we have here, that I apply here. Open circuit at DC. So you can pick 0 as the answer. I don't have the keys. Fine, it would help to have the keys, okay. In that case, I'll have to let me open a PDF with the key so that that's not one confusing aspect in this discussion. So this is one, very concisely. max VC when open circuit happens. When will this happen? That is at DC. So it's a different answer. Your VC, you can apply impedances, voltage division rule. So this is the 100. Phasor. Let's look at the magnitude, or let's write this in impedance form. This is anyways 100 0 degrees, right? So not a big deal. Here we have 1 by j omega c, and here we have, I'm writing summing the two impedances, where this is R, right? Quickly notice this is 1 by 1 plus j omega RC, 100 at 0 degrees. If you take magnitude, this thing disappears. I mean that thing goes to 1. Okay, and magnitude of this, when omega tends to 0, this is maximum magnitude. In fact, you can quickly see this one step down the line. This is square root of 1 plus omega square r square c square to 100. Right? When omega is 0, the denominator is the smallest, numerator, the whole term is the largest. RC 1 by 2 pi RC magic frequency likely will help you. The same question repeated somewhere down the line. Okay, it won't help you everywhere, but there is, I think, one more question where that approach will help you. Okay, that's a fair guess. Magic frequency, what is it? Okay, but you can answer this in one line. Max VC when this thing open circuits, and you can see that in the impedances. So omega 0, you have there is open circuit happening now. Yeah, move on. Finite impulse response FIR filter has only two non-zero samples in its impulse response H of n, discrete time Fourier transform. So for this question, I have to refer the definition of DTFT, nothing more. Okay, or rather, I have to recall it from Wikipedia. Let's write it. I'll get it to a stage where you could answer this. Now I am recalling from my the formula whatever I saw today morning. Okay, 0 to m. Say there are m terms here. This has to be h of n e power minus j omega plus j omega. Okay, let's put minus j omega. I suppose I am recalling this. Okay, as I said, if I had prepared for this, I'm going to write this down, but I am kind of like morning I referred wiki. Now I am recalling. I think this is correct. So there are this is a big summation of the m terms. They will tell you, hey, there are only two terms in h of n. So what this becomes is fairly easy. Only there are first two terms, FIR, rest of them are all 0. Only two non-zero samples. So the summation has only two terms, h of 0 into, probably there is an n somewhere over here. Okay, can some of you, even quickly go recall? Yeah, there has to be n over there, else, this is, you're not writing into components. So this is h of 0 into e power 0, that would be 1, plus h of 1 into e power minus j omega, minus j omega. So this is 1. Remember, this is 1. Can you find the magnitude of this? I'll give you 2 minutes max. Can you answer at this stage? Can you find the magnitude of this? get the answer keys. Oh, where I put answer keys? Okay, I got the keys, I suppose. Let's not spend more than 2 minutes on this. Okay. Hey, notice this is cos omega j omega, you know, 1 plus cos square omega uh, plus 2 cos omega, okay, plus sine square, right? So this and this is 1. So we have 2 plus 2 cos omega. Magnitude of that, you can reduce it to C. Okay? 2 plus 2 cos omega. Use cos theta to, cos 2 theta formula, right? You will be able to take that square root and then you get omega by 2. Okay? That trick step, all of you could do. From, here you have 2 theta, you have to go to theta. So that you will be able to take that square root. Hey, this appears, I recommend all of you focus Aryan, which formula? This is basic trick formula. What is cos 2 theta, right? It depends on square of cos theta. I'm not going to get into that detail right now. Okay. So in fact, I suggest all of you to look at focus more on core subjects, right? So this is from ADC, analog digital conversion. Okay, but this is actually one more question and fairly easy. So we'll just answer this and move on. So your clock frequency, you cannot sample faster than that, very roughly. Okay, for no aliasing, you should be within half of the clock or the sampling frequency. Okay, you should be within 0.5 megahertz. And I suppose the key here is C. What they are referring to is if you are using 8-bit and with a couple of text added here, you need to add one more bit for the start conversion, one more bit for where the thing ends. So you have roughly 10 bits. Okay, you need to have it's 8-bit approximation. So with the start and end, it becomes 10 bits essentially, or it needs 10 cycles for a single piece of data. Okay, so quickly, what do you get? 0.5 by 10 megahertz. What do you get here? What is 0.5 by 10? That is, at max you can sample 50 kilohertz. Okay, and that's why, here you can go till 49.9. At 50 you'll start having aliasing. So the maximum here is 49.9. That's all there is to this question. Okay, numerical wise. Theory wise there is a lot. Let's skip it. Question number 19. Did anyone get this question? Any of you got it, we'll do it. Else we'll do it at the second pass. If you know op amp, actually fairly easy question. If you do not know op amp, forget it. If you know op amp, anyone managed to get it? We'll do second pass. Yeah, there's an integrator circuit. Did you get it? Again, where is my answer key? I suppose the key is this, I suppose, or key is in this, I suppose. Okay, did you get this? Yeah, key has to be okay. Okay, we'll do second pass. No worries. If you got it, fair. Which one of the following techniques make use of Korotko? So all the Alva questions, I suppose you have 4 or 5 Alva questions, right? Pressure, sphygmomanometry, pulmonary artery, pulmonary vein. The only exception, right? It's artery deoxygenated, vein oxygenated. I suppose A, right? Yeah, that's correct. Which one of the following bridges cannot be used for measuring inductance? Maxwell Hay series 7. Sharing is for capacitance. Okay, partly recall at this stage, but can anyone concisely state why not inductance? If you can match capacitance, why can't you match inductance? In Sharing's bridge, the phase will be opposite. You can never get the inductor's phase using a capacitor. Okay, and in that configuration. So okay, the sharing, you can do capacitance. You can match the phase of capacitor, positive phase. Okay, you cannot make it negative. Fine. Fairly easy. Polychromatic beam, X-ray is passing through the body. So which wavelength will get attenuated? What are the units here? Energy spectrum passing through the human body. Horizontal, okay, they are mentioned. This is in energy, this is in kilo electron volts, and vertical axis is intensity. Number of photons per unit area, sometimes per unit time. Per unit area is good, I suppose. Okay. It's fairly easy. High things will pass through without, they just pass through with least amount of interaction. Least interaction. Most interaction. So this will attenuate the most. Low frequencies or low energy thing. They will stay, they will eat most interaction. So they will attenuate the most, that which interacts the most. So this part is attenuated the most. The original spectrum, I suppose, circle and all that, they have given it to confuse you. The spikes, the characteristic spikes, characteristic can never move. Characteristics remain characteristics. Perhaps their intensity come down. So this is. So what they are roughly saying is, hey, till 50 it will attenuate. From 50, most of it goes through. Hey, quick question. Are they referring to, is it in the same scale? No, the scale is different, right? The characteristics, can they move quickly? can the frequency change due to interaction? Hey, think about it. We have different scatterings. One of them direction changes, some of them frequency, Compton frequency changes, right? So probably that's why they have shifted it, right? Yes. Compton energies, frequencies can change, right? They lose some energy. Breaking, yeah, energy can change. Energy of the photons can change the interaction. So uh, the wavelength can change, frequency can change. So characteristic was at some place it can move this way, that way. Okay, how it changes, it's kind of becoming higher energy. Okay, let's not worry too much, but this is the answer. Okay, let's go further. MLT correspond to dimensions of mass length time. Again, there is typically at least one question you can answer based on this. Typically, there is also a direct question from this. Dimensional analysis, unit analysis. What is the dimension of viscosity? Simplest can think of as Pascal second. This is Newton per meter square second. Okay, this corresponds to kilogram. They mass into acceleration due to gravity. Meter per second square, and then you have meter square per second. These two. Okay, you have meter square per second, and that becomes Pi cells. Choose the option that has a biomaterial arranged in the decreasing tensile strength. So this is a composite, typically strongest compact bone cement, and then polymer foam, low density. Composite. Is a this a hard material. There's a solid. There's bone cement. Typically, what it interacts with the trabecular bone. So certainly not as strong as compact bone. So then, again, if you know some basic terminology, you can technically answer this question. So let's answer this. Okay, we don't have to do a second pause. Okay, is there anyone who can answer this? Is there anyone who can answer this? If not, we'll move on. We'll do a second pause. We'll do a second pause. Hey, we won't do a third pass. So if we don't do a question in the second pass, okay, we'll just pass it. One or two questions are like that, might be like that. Which of the following constituents is not normally found in serum? So, but the thing is, this is a doable question. Okay, if you understand the language, this is actually doable. The following constituents is not normally found in serum obtained from human blood. Serum. You also remove plasma proteins, coagulation proteins, right? Don't have this is a liquid part, no platelets. You remove coagulation proteins. So fibrinogen. Actually, this is a very interesting question. Okay, probably this is actually a nice trap. There's a difference between plasma and serum. Plasma would have fibrinogen, but serum will not have fibrinogen. B, albumina. Are we answering a different question? Probably for a previous question or something like that. Oh, that's a viscosity question. Okay, fine. It's actually a nice question. Clever question, actually. Here is Boolean variables XOR operator. Did anyone solve this? Perhaps we can do a second pass. Yeah, actually this is again solvable. We'll do a second pass, okay, for the convenience of everyone else. Human pancreas with cell type secrete insulin glucagon. Hey, this is yeah, some of these were actually directly from notes. Okay, we had a mnemonic for this. Can PAGA? We had a mnemonic, right? Can someone quickly remind that mnemonic? Beta insulin, alpha glucagon. PGA. I remember a nice mnemonic. Okay, but anyways, fairly easy to remember. Let's move on. Circuits question. See, we discussed bare minimal concepts in circuits. With those concepts, technically you could answer most of the circuit questions given here. This is one such question. Okay, it's fairly easy. So let me just do it. Okay, so this switch is open. T less than 0. T greater than equal to 0. What is the steady state voltage across the capacitor? This thing opens. Okay, at steady state. It's the DC capacitor opens up. So this thing is closed. What is the steady state voltage across this? The voltage across across the capacitor, the open capacitor is essentially the same voltage as we read it here across a 7 kilo ohm resistor. Okay, no current flows here. That means we can apply voltage division. So the 10 gets split between these two resistors, the ratio of 7 and 3 plus 7, that is 10. Okay, so this is 10 that is getting split. The answer I suppose is 7. If you have a 10 volt, you will see 7 volt across the capacitor. It's not even a transient circuit problem, fairly easy, it's just steady state. For a tissue of Young's modulus 3.6 kilopascal, Poisson's ratio, what is the value of shear modulus? Hey, can someone remind me of the relation? I suppose this is 2g 1 plus mu or 2 mu, 2 nu. 2 nu, okay. See, mechanics being your strong point, some might think it's a sin to not know this relation, but at the end of the day, it's just a relation which is available anywhere. So you don't have to. I don't have to um, load or clutter in my memory with this detail that I can easily look up. But for you, gate exam, you have to recall, right? At least till gate exam. So with this relation, what they are given is y, and nu they are given what they are asking for. What is this? Fairly easily calculatable, 30 seconds. Okay, so there is no 2 there, fine. So what is this G becomes? For me, it's not important. For you only, it's important till the gate purpose is done. Okay, recalling details like this. Fine. I suppose 1.5. Same unit as this, so this has to be kappa. Yeah, this is kappa. Fine. So you're back at the same question. There, this is from that playlist. If you do that playlist, see now this might help you. Magic free. Hey, they are asking for some frequency. I'll put that magic frequency. Okay. Amplitude of the voltage across the resistor and capacitor are equal. What is the value of the angular frequency? Omega naught. You can see this, in a couple of ways. Again, no. Technically, if you do magic frequency, it may not work. Unfortunately, it may not work here. There is one more question where I think it will work, but here it won't work. So voltage across the two are same. So this is roughly 50 at 0. Amplitudes, I'm not technically going to worry about the phases. There is a 50 here and across this there is a 50. So that's an equal split between them. I'm not writing the phases. I think we just saw BC gets divided between the two, 100 at 0. Based on the impedance we just did, this is 1 plus j omega RC. What we are interested in is the modulus value. And this, of course, modulus for this, that happens to be 50. That implies 1 by square root of 1 plus omega square r square c square equals 1 by 2. This implies omega equals 2 to the amplitude, becomes half. The power becomes half, probably the magic frequency work, but here it won't work. Can you quickly fill this one up? So 2 to square 4. It will be some minor fraction of RC. I don't know where I solved it. But can you complete it at this stage? From here, I suppose it's easy to find omega. So this is the ratio of half amplitudes or equal. Yeah, this has to be 50. So this is 1 by 2. This is 1 by plus omega square c. $300. Probably made a omega square is 3. Yeah, probably. I think I made a silly mistake while deriving, or I don't have the calculator. But let's just follow on and get a number here, and it's different from the key. Omega square is 300. So what is omega? Root 3, 10 root 3. 1.5. It's approximately 15, is it? Suppose answer key is 10. $15, 17. Yeah. Can anyone spot the issue? If you spot the issue, fine, else we'll just move on. This amplitude of this has to be 50. Split equally. 50 here, 50 here. Or did I make a mistake there? But probably, when I read 50 here, 50 here, let's see if there is a mistake there. Okay, but is the thing detail at this stage you have to address at the second pass. It's not time efficient to look at it right now. J by omega RC, will worry about it at the second pass. Okay, continuous time band limited signal x of t has a Fourier transform described by this. X of f is this band limited. Okay, is this a straight line? Signal is uniformly sampled at sampling rate 600 hertz. Fourier transform of the sample signal x of s. This is an easy question if you know what it is. Again, did anyone make sense out of this? It's easy, but did anyone make sense out of this? Else you'll come back. Unlikely, we'll come back. A time t cardiac dipole oriented at -45. Magnitude of the dipole is 3 millivolt, assuming nth one frontal plane configuration. What is the magnitude of this? 1, 2, 3 leads. Remember the hexaxial direction. You have lead 1 horizontal. At 60 degrees, you have lead 2. At 120 plus 60. Okay, there is a 60 here, and then there is a 60 here. At 60 degree, you have lead 3. You can also put 3 other augmented leads, but for this now, what is given is the cardiac axis is somewhere over here at 45 degrees. The amplitude of this is 3 millivolt. The angle between them will be 45, 60 minus 45, that would be 15 degrees. The amplitude of the cardiac vector along this line, that will be this length cos of 15, 3 cos 15, and that happens to be 2.89, 2.9, 2.9. Okay, 5 megahertz ultrasound transducer being used to measure the velocity of blood on the transducer based at 45 degree direction of flow. Frequency step 200 hertz is observed in the echo. Tell us, assume the velocity of the sound 2u cos theta by c f a. I have done this so many times. Unfortunately, my memory is cluttered with this, but del F's Doppler shift is given, frequency megahertz is given, speed is given, theta is given. They want to find u, velocity of light. I'll give you 30 seconds to a minute. U in centimeter per second. Probably 2 meter per second, then you can convert that into centimeters per second. This conversion is fairly easy. Okay, let's do this first, then enter this. Because this is an SI, and SI to that is fairly straightforward conversion. What you need is this. .24. Independent growth of a bacterial population. Okay, initial population size is x naught. Population size of the bacteria asymptotically approaching. I said, you don't have to solve this differential equation. They are asking you what happens. T equal to infinity. The solution doesn't change. That is, dx by dt is essentially 0. So what are the roots of x into 1 minus x by 200 equal to 0? Either it's a 0 or x by 200, right? It starts at x equal to 100. Some of the students, the moment they get your number, they start calling you at arbitrary times, which is why I avoid giving contact number. So this is probably x equal to 0. This is saturating towards, it's going away from x equal to 0, I suppose. And 0 is not over here. So x equal to 200 is a solution. Probably that. If 0 were there, then you have to do some additional stuff. But at this stage, you can answer. Right? Asymptotic, it is not changing. What are the roots of RHS? So LHS is not changing. What are the roots of RHS in that case? 200 and 0. So 200 is here. Okay, did anyone solve this question? Hey, this is Gaussian noise, some signals and systems, some statistics and all that. Actually, it's slightly, there might be a simple formula underlying this, but slightly involved signals and systems. That is, if you're starting from first principles, that formula is not that close. Okay, I'm going to skip this one question. I think this is the question that I didn't think a lot about. Okay, if the formula is there, perhaps it's like a one-line answer, but from first principles, I suppose it's slightly answer is fairly away. So I'm going to, it's not even a second pass question, perhaps it's a third pass question. Let's move on. Circuit below, the two DC voltage sources have voltages of value V1 and V2. Expression for the power dissipated in the 60 kilo ohm resistor. Hey, already this is 320, is it? 1 hour, 1 hour is over. Okay. Expression for the power dissipated in the, quickly, yeah, concisely, how do you solve this approach? Can you say something? Oh, superpose. Fine. Oh, it's a linear problem. So, just apply this voltage and then apply that voltage. It's fair. Actually, that's a nice point. Superpose things. Voltages are linear, but once you calculate voltage, power is, you can calculate power based on that. After doing, finding voltage by superposition, you can find this thing. This is, this is a one variable problem. In the morning when I did, that's how I did. So there is this unknown V here. So the current, the three currents add up to 0. The first current V minus V1 by 10K plus V by 60K plus V minus V2 by 20K. They all add up to 0. The three currents add up to 0. The V is the only unknown variable. Once you know V, notice the power dissipated is fairly straightforward. V square by R. Right? So find V. You multiply by 60. 6V minus 6V1 plus V. 3V minus 3V2 equals 0. 10V equals 6V1 plus 3V2. They're asking what is it proportional to, so it's proportional to the voltage here, contribution of these two or in the ratio of 1:2. Right? This is 2V1 plus V2. And energy power dissipated, this is V square by R, square of proportional to square of that. See, we'll also get that by superposition. See, superposition, you will have to do this parallel resistor series. You have to find the combined parallel resistor, equivalent resistor, then apply voltage division. This parallel resistor, apply voltage, fair, fine. Again, 2-3 lines could technically do this. This again is fairly easy if you know what they are asking for. Let's do a second pass, some non-core question. This question we have to do, you have to do, certainly. Did anyone get this question? Circular disk of radius R has a uniform absorption coefficient. Consider a single ray passing through the disk and the plane of the disk, shortest distance from center of the disk to ray Ti is the intensity of the incident ray, I naught is the intensity of the transmitted ray, log I naught by I by I naught. I'm trouble understanding the language of this question. Okay. Same. Yeah, this is what I refer to as, it's a classic example of what I refer to as gate likes to obfuscate. They have done this in this question. It's actually fairly say, all of you know how to do attenuation problems. All of you know how to do attenuation problems, right? This obfuscation actually is, some of you will play this games called Pictionary or something like that. There will be two friends. Okay. Team will have two members. There will be a sentence or, something like that. Or there will be a picture. One person can look at the picture, the other person cannot. They have to look at the picture and describe the picture to the other person, and the other person has to draw it under some constraints. Okay, so here the real trick is to convert this text to picture. If you do that, this is one of the easiest questions. I'm doing that picture version here. Light is passing at a distance t from the center. So it is getting or attenuating. This distance is t. This distance is t. So through the disk, light enters here, gets attenuated, exits here. Can you solve this problem now? This is R. Let's draw that in gray. This is R. This distance is t, and it's a perpendicular distance. This distance is t, and this technically is also R. Can you solve it right now? Now all of you, it travels a distance of 2 times square root of R square minus t square. Pythagoras, where is that coming from? Some of you might be wondering. This length is square root of R square minus t square. So it travels twice that distance. So intensity I equals I naught e power minus mu into distance. And that distance, yes, it travels a distance of this, right? So this is where, it's a well-known question, but by the way it's phrased, I could empathize with you because I had trouble understanding it. But because I had gone through so many questions, second or third time I kind of realized, hey, this is the simple thing that they are asking. And in fact, for me to actually recognize that, I had to anticipate probably a simple description, complex description of a very simple thing. I had to kind of anticipate it. I tried that possibility, happened to be the case. Okay, not always the case. In this case, okay, distance is this. So yeah, I over I naught, probably in terms of their language, incident and exit. I have to. This is incident. This is what exits. So this is what incident. This is what exits. So you can do I or I naught, and then you can take log of that. Probably it's proportional to t. Okay, that step you can complete. T induction decay of an MRI object. Did anyone answer this? Probably some of you are like are smelling the meaning in the question. Again, this is obfuscated. If they give you a picture, pulse sequence or the trajectory in the space, it's evident. They are given you equations. What they are saying is the signal that you are measuring is essentially inverse Fourier transform of the image Okay, and the inverse Fourier transform, notice in the inverse Fourier transform depends on how you are moving, applying the gradients in the x and y direction. So where you are in the k space depends on how you are applying the gradients. At the end of the day, your signal is an inverse Fourier transform. So given the signal, if you take Fourier transform, that is, if you look at the k space, you get your image. Okay, that's a connection that they are making. In this case, image is a easier thing that we have seen in class notes. They are given an equation, but some of you might have made that connection fairly easy. So these are radial lines, gradients in both x and y, radial. A magic frequency might work here. In the circuit shown below, observe that the amplitude of voltage across the resistor is same as the amplitude of the voltage source. What is the angular frequency? Oh, for this, these two reactances should cancel each other. Or there is a positive phase, there is a negative phase. They have to cancel each other. So this is the case where you have Xc equal to XL. Probably 1 by omega C equals omega L. Okay, the magic frequency is likely. This case, omega square is 1 over square root of LC. They're asking for frequency in rats, so they're not asking for F. That is, no. They're asking for omega. Can you quickly find omega? So quickly, the purely capacitive and inductive term cancel each other. The statement, one way, quick way that you could do it in multiple ways. Quick ways. That statement implies capacitive and inductive impedances cancel each other. Impedances cancel each other, and for that to happen, XL equal XC. Okay. Okay. There, I suppose this is 1 by this. Is it 10 power 4? Fairly easy, right? You can clear. I suppose most of you would have cleared the exam by at this time, right? 1 hour 15 minutes or something like that. Okay, around 4-5 questions you have left for second pass, but by now technically you should have cleared. Okay. Hey, by some Malwa questions down the line or recall questions. Biomaterial formation of hydrogen bonds, alcoholic groups will lead to. Suppose this 3500. Fine. You might have done a second pass, but does anyone recognize what kind of a circuit this is? If they ask at what F maximum power transfer, then it is modifications. Perhaps we can look at it as second. Okay, let's just pretend we are in an exam trying to give it. During the exam, I wouldn't be during practice, I would be thinking of alternate versions. During the exam, answer and move on. Okay, only I'll check if I have fallen for a trap. Okay. Does anyone recognize what circuit this is? I'm not going to do this at the second pass. If you recall, this is what we call as a voltage multiplier, specifically a doubler. Voltage doubler. So whatever load you have, a voltage you have here, that's going to double here. So if you apply 2.5 peak to peak, you should get 5 peak to peak. It should double peak to peak. Okay, you have to recall. If you couldn't recall and all that, fine. Skip this. Ultrasound plane way of. There is always this one thing. Part of it reflected, part of it transmitted. There is always one question they give this question. So PR by P naught reflection coefficient, I suppose Z2 minus Z1 by Z2 plus Z1. I suppose, is this correct? I had to recall this from our notes morning. Don't need transmitted. Incident is just P naught. So let's just take it to this side. Well, they are sum of P naught and PR. So this is P naught 1 plus Z2 minus Z1 by Z2 plus Z1. And I suppose Z1 cancels to Z2. Okay. Circuit given below, what should be the value of the resistance R for maximum power dissipation in R? Does anyone know the condition in one line, in 2 or 3 words? You don't have to do a second pass. I'll explain this. Okay. In a circuit like this, you have a resistor, you have a source, and you have a load. Max dissipation, max thing in the load happens when max power transfer, when R equals RL. This is the condition. On top of that, given circuit and this circuit are different. So what do you do? Yeah, you have to replace this part with the Thevenin's equivalent. In that case, this becomes R Thevenin. You have to find, R Thevenin. Can you find R Thevenin of this circuit? That's what they are asking for. When RL equals R Thevenin, you get the maximum power transfer. That will be R Thevenin. Let's also do that. Short voltage 2, 3, 1 across this. So you have 1, 2, 3. Probably this is 1 plus 6 by 5, 1.2. 1 plus 1.2, 2.2. Okay. This voltage technically need not be 10, but we don't have to find it at this stage. Okay. It suffices to find R Thevenin. So, 2 sequences X1, Xn are described as follows. Did anyone get this? They have set a trap here. X0, 0, 1, X1, 2, 2. So they are shifting the order. So the first signal X1 is 0, 1, sorry, 1, 2, 1, 1, 2, 1. The second signal X2 is 1, 1, 2. If you write 1, 2, 1, that's a mistake that they want you to make. So given these two, we can know how to find the convolution. So 1, 2, 1, 1, 2, 1, and take that, multiply by 2, 2, 4, 2, 4, 2. So likes for the first pick, likes for the second pick, likes for the third pick. So each day, the number of likes you have here, 1, 3, 5, 5, 2. Okay. If you look at the indices, 0th day, first day or index, technically n. Okay, day is our analogy. 1, 2, 3, 4. X of 2 is X of 3. That's correct. X of 1 is 2. No. X of 4 is 3. No. X of 2 is 5. Total number of likes is a convolution. Okay. Like for pick number 1, first day 1 to 1. For the second pick 1 to 1. Third day you upload actually better pick, twice a better pick. So you get like 2 for 2 likes, right? On since the day you upload. Okay. So no second pass for this again. Say you can expect a convolution. The real trap was here. That also I kind of mentioned. Okay, the trap is here. The rest of the terms are all 0. You don't have to worry about them. This way, that way, 0. Okay, some complex number A, if it is within the contour, if there is a singularity at 1, if the singularity is within the circle contour, you get a non-zero value. The radius is 0.1, centered at 2. This is a too small a circle for 1 to be inside it. You won't get a, you will get a 0 here. Radius is 0.1, centered at 1. 1 will be inside that. So you get a non-zero value for B. You get a, this is actually centered at 3, radius is 5. Bigger radius, that will have 0.1 inside it. So this is again non-zero value. Radius is 2, centered at 0. 1 will be inside. So this is non-zero. PCD, fairly straightforward, right? MSQ, I suppose. Continuous time signal x of t is described by x of t is 1. Y of t represents x of t convolved with itself. Does anyone know if you take a rectangle convolved with itself, what kind of a shape do you get? So here you have x of t. You're convolving that with x of t. So you're moving this left and right and seeing what the intersection is. So you have x convoluted with x. This will be a triangle at the end of the day. This goes till 1. This goes till 1. If you know some bit of convolution, you know this is a triangle. Okay. Having said that, can we answer right now? This has to be 2, 0. So this is a convolution. This is a signal. This is y of t. Now can you pick answers? Y of t 0 for less than c. I suppose this is correct. Greater than 1 is 0? No, it's greater than 2, it's 0 actually. So this is correct. This is correct. Can we answer this? dy by dt is a slope. Slope between 0.1 to 0.75. If you integrate, the slope is non-zero. If you integrate it, it's going to be non-zero. So that has to be correct. Non-zero slope. Finite value integrated, you're getting a constant. Perhaps it's a constant, but non-zero. D is correct. Hey. Recall. Lung volumes. Lung volume measurements. Can someone reliably tell me quick the answers? AC. Fine. AC. A recall based question. So I'm not particularly spending time on it. Time and also some energy. Okay. Still more questions to discuss, right? So assuming the operational amplifier in the circuit to be ideal, which of the following properties holds true for the circuit? Is this a voltage follower? We can answer this. We don't have to do a second pass. We can answer this. Is this, does it, can anyone answer this? If the loop were in the negative terminal, that would have made it a voltage follower. In the positive, so your ampli, you know, there is a positive feedback loop. It's an actually unstable system. Depending on what you set here, it will either go to positive saturation or negative saturation. Okay, it's a bistable system. It's either, if this is 10 volt and -10, it will either be in these two states. Okay, the voltage, output voltage will be at saturation depending on what is the reference here. Fine, you don't have to spend any more time on this. Water soluble polymeric material can become water soluble. Water insoluble can become water soluble. By which mechanisms? Probably if you have water soluble polymeric chains, yes. Non-polar groups, it won't be soluble, right? Cleavage of backbones leading to polar groups. If water is polar, so if you have polar groups, yes. Enzymatic degradation between water soluble. Yeah, there's probably, this is also correct, I suppose. Correct? Yeah, water is polar. For something to be soluble, it better be polar. Fine, is that correct? Can we move on? Okay, this question in MSQ answered f of x, f dash of x, f double dash of x. There is no boundaries given. So slope is the slope 0, roots are 0 plus or minus 1 by root 2. F double second derivative check. Okay, it's a function symmetric about x. Yeah, this is an even function. X power 4 is even, x square is even. It's an even function, so that's symmetric about x equal to 0. That's correct. Minimum value is a minus 0.5. No, minimum value happens to be, I suppose, minus 0.25. So this is incorrect. Has two minima. Probably these two. Yeah, this is a square term, right? So this is always going to be positive. So these two are minima. Has two minima. That's also correct. Function is an odd function. No, function is even. And all options. So A and C. Let's move on. Okay, I've written something complementary function, particular integral, presume. Okay, the initial conditions, differential equation is given on the LHS. This is a driven system. You have an input. Initial conditions are not given, so you'll have to presume it to be something. Okay. Okay, at t equal to 1, what is the answer? Did anyone fully solve this differential equation within 5 minutes or something like that? Or better, did anyone do this in less than 2 minutes? We'll have to get back to this question. The resistance of a thermistor is 1 kilo ohm, 25, 500, 50 degree. Find the temperature coefficient of resistance. Temperature coefficient of resistance. Again, notice this is actually a question directly from class notes. We talk about some sort of sensitivity when you talk about thermistor, right? That sensitivity happens to be the temperature coefficient of resistance. I'll give its definition over here. Did anyone manage to solve this? So for a thermistor, probably I need some space for this question. So let's do it over here. Suppose R is R naught. Let's do it over here. R equals R naught e power minus beta 1 by T naught minus 1 by T. You can write it in slightly different, and this is the form that I prefer. R naught T naught, okay, minus beta naught minus 1 by T. Concisely, what they are asking for, 1 by R dr by dt. We mentioned something called sensitivity in class. Essentially what they are asking for. Okay. In fact, alpha, the temperature coefficient of resistance, this will be 1 by R dr by dt. I think we did this derivation in class, and this is plus or minus beta by t square, where this beta is this beta. Units of this will be units of Kelvin, so this will be units of or Kelvin or degree Celsius. This will be in units of degree Celsius. So resistance at 2 points, temperature at 2 points is given. They are asking me for alpha. Quickly, can anyone find this? Can you state it that way, in simple terms? Let's not really do a second pass. Okay. Find beta. So given 2 points, 2 resistances at 2 temperatures, you can find beta. Yeah, find beta and then find alpha. Okay, I think we kind of did this in class. So uh, we defined it sensitivity. The name is temperature coefficient of resistance. Let's not do it the second pass. That's it. But Vigneshwaran, what is the key for this? The only trap that I am concerned about is between this is in degrees Celsius. Kelvin is beta in Kelvin or degrees Celsius. That's the only detail I have to be slightly careful about. Let's put beta in degrees Celsius. So that's the only detail I will double check. So this number is between, answer key I suppose is between minus 0.03 to minus 0.025. So all the values are in degrees Celsius. Technically, if you stick to degrees Celsius, you should get correct answer. Find beta in degrees Celsius, find alpha in degrees Celsius. You may not need to jump to Kelvin, okay? That's one detail I'd be cautious about. 0.028, yeah, number, probably 0.28 is good. Okay, that's good. Notice again, this is directly from class notes. Move on here, 14 energy. So this amount of energy is passing here. What is seen at the detector in terms of electron volts again? Okay, so intensity, energy kind of drops as it passes through. Probably a monochromatic light, I suppose. We'll have to presume that. No other go. You have what is entering here is 140. What will be entering? That is after traveling 1 centimeter. What will that be? That be 140 e power minus mu. Mu is 1 centimeter per inverse, distance of 1 centimeter, e power minus 1. So that much comes till this point, and that is what enters this medium, travels a distance of 2 centimeter and hits this end. This end, so whatever this enters, what do we have here? What enters into attenuation. Attenuation is e power mu here, I suppose, is 10 into distance traveled 2. Okay, how much is this? Hey, homogeneous jumps discontinue, non-homogeneous medium and all that we have done in class 2020 and all that. This has shown up many times. This is 106. Right. 2-dimensional square plate, 20 mm sides, contains a homogeneous circular inclusion, 5 mm diameter. Slightly better question is that I have in the diagnostic. This is the park example that we discussed. Hey, you are taking pictures of the park. How many pictures do you need, right? Essentially that question. But the dimensions to make sure that you can cover the detail in one view. Okay, this is 20 mm. You're using X-ray beam of 30 mm, so you can pretty much cover the entire plate, and certainly this sampling, that sampling, even after accounting for sampling and all that, you can certainly cover 5 mm with a width of 30 mm. But to locate X position, you need one view. Locate Y position, roughly you need one. Okay, so you need 2 views. You look at it from this direction, you look at it from this direction, 2 projections, you can technically get this, not an issue. Calculate the reciprocal of the coefficient z cube in the Taylor series expansion. They are asking you for residual. The residual will be 1 by z. No, they are okay, but this is not 1 by z. They are asking for coefficient of 1 by z cube, right? Sin z is z. Z cube by 3 factorial, Z power 5 by 5 factorial. Coefficient of Z cube, reciprocal of that. So coefficient of that is minus 1 by 6. Reciprocal of that is minus 6. Did anyone get this? I left a note at the end of the class when we discussed Beer-Lambert's. The answer is supposed to be 42 to 44 point. Somewhere here, and I'm asking this because did anyone get it? Because I know this is slightly obfuscated. 0.2, you have to be careful about one detail that I mentioned at the end of notes. Else, we will come back to this question. We'll have to come back to that question. Volume of percentage of oxygen in inspired air is 20%, expired air is 16%. Person is breathing 12 breaths per minute. In each breath, 500 ml volume. Cardiac output 5 liters per minute. Assuming ideal healthy lung, cardiac conditions. What is the change in percentage oxygen in blood over a minute? Let's do everything. Did anyone get this? Fairly easy, right? In 1 minute, everything in 1 minute. 12 breaths. Everything in 1 breath. 12 breaths. That is 6 liters. 500 ml in each. 6 liters. Correct? Inspire, 20% of this 6 liters is oxygen. Expiration, 20%, 16% of this 6 liters is oxygen. So 4% of 6 liters. How much is this? Hey, I left my calculator somewhere. Can someone give this number? 4% of 6 liters. 0.24 liters. In a minute. So this is what happens in the lungs. This is what happens in the lungs. You know, ventilation perfusion ratio approximately 1. What happens in the lungs, that much oxygen gets used in the body or in the, the heart or the cardiac output, right? So this is what happens in the body or the heart, cardiac output or the body, okay? So this much amount of oxygen gets consumed in the body. So that is 0.2 liters in 5 liters of blood. How much? What a percentage is this? As a percentage, what is this? 0.2 liters in 5 liters. Suppose that's the answer. Let's also have this in green text. In the body, we're talking about the same amount of oxygen, 0.24 liters. Okay, but as a percentage relatively with respect to 5 liters of blood. 5 liters, this corresponds to 4.8%. That's it. That I suppose is the answer. Intracellular, extracellular concentrations of 3 important ions are given in the. Yeah, this is more like aptitude questions. Really, see, most questions are aptitude questions. Actually, with common sense, you can clear the gate exam. And that's always what I feel, okay. With aptitude, some common sense, some biomedical literacy, you can technically, if you're good at aptitude, you can clear the paper, okay. Intracellular, extracellular concentrations of 3 important ions. Okay, one word, what formula do we use? Nernst, Donald, Goldman. Yeah, fine. You know this, I have already pointed out technicalities about it. You know, those in class, those who are watching the video, there is a bioinstrumentation questions where these are all given, okay. before 2021 and all that I have given these questions. So Goldman, the answer I suppose is somewhere in this range, 84 or something like that. Okay, 82.6 to 86. Goldman equation. You have to recall a formula, fairly standard formula. Okay, 83.6 millivolts. They gave you gas constant R, fine. They gave you Faraday's constant. He also gave you temperature. Notice this is in Kelvin, so you'll have to do temperature in Kelvin. Even otherwise, this is body temperature, room temperature. You can make, approximately what it amounts to. So only the logarithmic part you'll have to calculate it. Okay, metallic strain gauge with negligible piezoelectric effect is subjected to strain. Strain is given. Modulus is given. Poisson's ratio is given. Change in resistance if the unrestrained resistance of a strain gauge is del R by R is G epsilon. They are asking for change in resistance. We know R, and they have given this is essentially 1 plus 2 nu. They are given nu. Poisson's ratio. Young's modulus, you don't need it for this question. They have given you stress. To calculate strain, you need the Young's modulus, but you know the strain, right? So all variables given, just find del R. Del R happens to be 18.4 ohms. No issues there, I suppose. You would need this piece of information if stress were given instead of strain. Okay. Right now, you don't need this information. Calculate the moment. Consider total hip joint processes as shown in the figure. Geometric parameters, so on and so forth. Calculate moment. Again, see which definition of moment. You take components. What would give the answer very easily? So you have to take moment about point C. What is the simplest way to do this? Joint reaction while waiting for some replies. This is 400 newtons. L1 given to be 40 mm. This is given to be 60 mm. This is right angle, no complications there. This is 45 degrees. Fine. Simplest would be force into perpendicular distance. What is the perpendicular distance? So this is the line of action of the force. Perpendicular distance between the point of interest and the line of action of force. If you know this detail, force times the perpendicular distance. This is L1 cos 45 degrees. Okay. And so moment about point C, this is just 400 into L1 cos 45 degrees. And if you put that in appropriate units, I suppose you get 11.5. 11.3. Anything between 11 and 12 works, I suppose, according to the gate key. Okay. 11.5 newtons. Newton meter. Say in 2 hours, our first pass is done. 64th question, right? We are close to an error of paper. So it's like a try run, sort of a hand holding session on time management, and also going through the paper, quickly explaining things that you need to watch out for, what they are trying to do in the question, how you are supposed to quickly arrive at the answer and all that, right? So in 2 hours, you have done the first pass. So by now, if you have done the calculations without lots of silly mistakes and all that, left over like 5 to 10 questions. 65 questions, 65 question JE question, 12, not even JE. This is a neat question. Okay, stone thrown. I have seen this question, right? Projectile motion. So I am not, do that. Which stone bridge? Let's do this. R1, R2, R4, R4. So 2 on compression, 2 on tension. This is a full gauge. E in as a 10. V out depends on V in. G epsilon. It's a full gauge, so this is 4 by 4. N is 4 by 4, right? So the coefficient is 1. If it's a quarter gauge, it's 1 by 4. Half gauge, it's 2 by 4, and all that. G is given. Del R is given. R is given. So this is in terms of this. So this factor is 1. Del R by R into Vi. Right? And they haven't given signs, bro. So they are asking you for they are not asking you for the amplitude. So technically either sign should be fine. Vi is given, V naught is given, R is also no V naught you have to find it. R and Del R are given. Is given, this is given. What do you get? You notice the signs are not defined very well. So either should work, I suppose. Yeah, plus or minus 1. 20 by 200 into 10. 200 by 200. 1. They haven't given the mention that direction, so either answer is 2 hours. Okay. Technically, let's see how many questions are there for the second pass. We'll do the second pass. I'm going to deliberately waste 5-10 minutes here. At this stage of the examination, some of you might take a breath. If we need to go to the restroom, perhaps this is the time. During the exam, not right now, okay? How many questions did we leave? 65, 1. 2. 3. Many more questions is there? Okay, 3. 4. 5. 6. 7. Let's say there is a mistake or related. 7. Yeah, are we still, are you not into the 2 marks? Yeah, here. So let's say 6, 7, 2 marks we left, okay. 14 marks is lost. Let's say. How many 1 marks? Let's do some double counting, that's fine. So we have like 1, 2, 3, 4, 4 marks. So right now 18 marks. I left a 3 mark here, I suppose. 2 mark I. Yeah. I think these are all fairly. So by now, how many marks did we leave it for the second pass? I just counted roughly. How much is it? 14 2 marks. 4 1 marks. Aptitude, there was a 2 mark. How much does it add up to? It's a hard question. 14 plus 4 plus 2. 20. Notice we are somewhere in this range. And I kind of openly mentioned, hey, this is something I had to recall. This, that, and all that, right? So we are common sense, biomedical literacy, we are in this range. 100% accuracy, 80 marks. Then if you are like 70% accurate, you are in single digit All India rank right now. At this stage, 2 hours down the examination hall, only answering easy questions. Some of the non-core questions you don't know that and all that. Accuracy need not be 100% fine. Some questions might have taken some calculations, some and all that. So 2.5 hours, you could have technically solved for 80 marks, out of which you could have got around accuracy around 60%. You could have got around 50. You are in a single digit All India rank. Okay. Technically, that's how the paper. That's how the easy the paper is. Now, let's do the last mile. This is 96 plus nothing even. Okay, I took some help, so now I have already taken the help. Okay, so I don't have to refer to them again. But let's go and solve all the questions that we kind of left. (2022) is the toughest, least biomedical friendly, most non-core questions were really hard, and that's also the year when our students got All India rank 1. 2022, right? He sang a song and all for our class, so I think there on YouTube, right? So let's do the second pass. When in doubt, start afresh. Okay, don't there is a mistake, don't jump on top of the existing forest land. Is it is tiring, but you'll have to do that. This is biomedical paper. Technically, yeah, right now, I'm like All India rank, single digit All India rank. So why do I solve it? No, make use of the entire 2 hours. Okay, at least 1 or 2 marks. Try to get the competitive edge. Don't underestimate your never underestimate your those who are competing with you. Okay, forest, different kinds of creatures. You have creatures, some of them are animals, all of whom are ferocious. So this ferocious, all animals are ferocious. This is forest, this is fero. Also creatures that have claws and some that do not. This can technically be here. There are some creatures that have claws, some do not, but they fall within the ferocious. They can intersect the animal, and I have gone this way, that way, out of animals and all that. All creatures with claws are animals. So this is our claw. Notice there is some region outside of animals. So certainly not the case. Some creatures with claws are non-ferocious. No, if they have a claw, they are strictly inside ferocious. Some non-ferocious creatures have claws. No, there are non-ferocious creatures some non-ferocious creatures. Non-ferocious is this layer. Non-ferocious creatures, they cannot have claws. Okay, not possible. Some ferocious creatures or creatures with claws. Some ferocious creatures or creatures with claws. Yeah, somewhere there. Okay, probably there was a mistake there. Okay, I'm not going to bother about it. Start afresh, get done. Okay, 6. Let's move on. This we are done. So all of you check the interface, I suppose. Gate interface, right? I think so. While going down there, I kind of realized where I made a mistake. Integrator, differentiator, that and all I don't know. This is 0. This is 0. There is current here. Okay. So Q is CV, current is C, dq by dt, dvi by dt. That current should better be equal to minus V naught by R. Based on the direction given here, this is V naught minus 0 by R, V naught minus 0. So your V naught is minus RC d vi by dt, which is where they set your trap. Is this correct? They mention voltage is a constant. So at this stage, let me not jump that step. Voltage is a constant. So this term is 0. So this is 0. Okay, there is a 0 answer. It's tempting to choose that. But while trying to look at dV by dt, I go look at it. Vi is a constant. But I know there is some change, displacement capacitance happening here, some prior knowledge. X is x naught plus kt. So I know this is not the answer. What happens? This is a very interesting problem where V is not a variable. They have almost a input source based on displacement. The capacitance changes. This changes. So when you take derivative dq by dt, that is I, that is Vi dc by dt. Okay, so you have I is Vi dc by dt, that is minus V naught by R. So I equals I. From that I get V naught as minus R Vi dc by dt, and that if you take C is minus R Vi epsilon A by x dx by dt. Right? So differential of the whole thing, this thing into derivative of x. Okay. The x is in the numerator, denominator x square. I might be making a jump. X derivative of x is dx by dt is k. What is dc by dt? We'll have to have a x square here, right? Is there a x square here by any chance? Epsilon a only derivative of this. Yeah. X square, and this will become a plus. Okay. Yeah, this term is c. So r bi epsilon a by x is c. There is a k. One more remaining x, and there I got my option. Epsilon is a constant, a is a constant. Only x changes. So take derivative, that will be 1 over x square dx by dt. That will be dx by dt as k. This detail is coming from here. Okay, again, I presume couple of you could have answered this. Okay, 1 mark, fine. Got that 1 mark. At the end of the day, it does matter a lot. Let's move on. See, yn depends on only x. That is what we call as a finite impulse response system with FIR system. The moment it depends on y depends on y, it's an IIR, infinite impulse response. The number of likes that you get never stop. Infinite impulse. Okay. You are going and putting likes. You are allowed to put likes. You go and keep on putting likes of a sort. So the moment you have this thing never terminates. There I get my first. Is it finite number, infinite number? I know it's infinite number. Very briefly. Impulse response 0.5. Fine. U1 is a unit step response. Not sure why it should be that way, or on impulse response technically should be. I don't see why this has to be impulse response here. The real next keyword that I am looking at is the input is bounded, is the output bounded. That is, let's say xn is a nice function. Will y, subsequent y's, will they remain stable in this case? Xn is nice, so I removed it. First value of y is given, you are calculating the second value. With the second value, you are calculating third value. Third value, you are calculating fourth value. Is it the y? Do they remain bounded? At this point, I know I have an IIR system, so I chose option C. It's not a very hard question. So is this equation, does as n increases, does y of n keeps on increasing? It is half of the previous value. Next time is quarter of the previous value. 1 by 2, 1 by 2 power 2, 1 by 2 power 3, 1 by 2 power 4, 1 by 2 power n. GP, decreasing GP sequence. As far as x is a nice function, y is also a nice function. That is, as far as x is bounded, y input is bounded, output is bounded. This is correct. The way I make that call, technically you can take Z transform and do this systematically, but I am making a very educated, some of you say, hey, this is an aptitude question, right? Some with basic literacy, I'm doing that. Not biomedical literacy, some basic signals and systems, some more literacy, some biomedical syllabus literacy, I can do that. Bounded input, bounded output. And I really, this is not a system where I am expecting a negative one. So I don't expect impulse response. It looks like a causal system. This is a non-causal system. Okay, there are many odd things about this. I know this is not is not good. I just ruled out finite number. I ruled out this. So B and C. There are many reasons to rule out this one. Impulse response is U of minus n. This side is actually, it's a very absurd system. Okay. nothing related to this fairly decent system, simple system given here. Okay, let's move on. Okay, how would you solve this at this stage? At this stage, XOR, we are trying to pull something from our first year, second year. This is analog electronics. Two variables, 0, 0, 0, 1, 1, 0, 1, 1. I know for a XOR gate, the output is 0, 1, 1, 0. I know this much. Can we answer this question? Hey, is it associative? From memory, something memory tells this is associative, but can you quickly put this? You can put values and check. Let's say we recall XOR 0, 0 is 0. If you have one more 0, you get a 0. So 0, 0, 0. At least, one or two test cases, it remains associative. Fair, pick it. This is 0, Boolean variable. QRS or 0, 2 or 0, third variable has to be 1. Let's say these two are 0. These two are 0, then you have a 0 here. If the third variable is 1, you get a 1 here. So it doesn't make sense. I just made Q0 or 0. That implied S has to be 1. And then we get a 0 or 1. We get a 1. Doesn't make sense. So option B is ruled out. I'm testing very simple cases. All three are 1. This is 1 and 1. This is a 0. 0 and 1. That's a 1. That's correct. Here, some property can help. Some algebra, Boolean algebra simplifications can help. This, that, and all that helps. Let's make this 0. I'm just going to try some special case. If it works in a minute, I answer it. Else I move on. But it has to be 0. Pick something sensible. Let's say 1 and 1. If you have to pick this 1 and 1, this is 1. This is 1. I'm just going to see if I get consistent 1 on the LHS. Okay. This is 1. Let's pick R0. What is QR? This is 1. This is 1. Okay. The combination is a 0. 0 combination 0 is a 0. Is given to be 1. I know at this stage. Some simple case. Yeah, 1, 1, 1. Some test something. Okay. It's not the case. A and C, I got it. A is slightly tricky. Agree. Again, test some simple cases. Okay. Either recall or test some simple cases. This much of XOR. You are very close to actually, you can make a reasonable guess in a matter of minutes. Let's move on. Yeah, I realized where I made this mistake. Yeah, I shouldn't have done this as 50 and 50 amplitude when I had complex numbers and phases like this. Okay. B across a capacitor is this. Voltage across a resistor. I'm going to, let's say we are using a new scratch paper. Voltage across the capacitor is this. It's amplitude, but also what is the voltage that makes voltage across the resistor? Minus this. Now let's do this. VC is PR. mod BC is mod BR. Hundred common on either side disappears. I'm not going to worry about that 0. Modulus of 1 by 1 plus j omega RC equals j omega RC by 1 plus j omega RC. Hey, the magic frequency works. Damn. Or am I jumping into answers? Okay, I think the denominator cancels. Only have the numerator. Omega RC is 1. Omega is 1 by RC. So getting back to our magic frequency, what do we get here? Again 50 now. Hey, we have nice numbers. 1K and 100 micro. 1. There is no. You got nice numbers here. The denominator just got cancelled. Numerator said it's omega is 1 by RC. 1K, this is 100 10 power minus 6, 100 10 power minus 1. So 1 by 0.1, that is 10. Okay. Yeah, I read it. This is where I made the mistake. Hey, amplitude, this 50, this 50. Complex numbers, I have to handle it with some care. So I split it. I just got that. 4:30. Hey, we'll just finish this picture. Okay, we are almost 3 hours, 2 to 5, let's say. Yeah, this is one question. I really did not think about this question. Okay, that's at 95 plus 96 plus when I said I was actually having this question. Okay, you have e power minus t, you have et in the left hand side. What you're looking here is this function, e power, a decaying function. So any exponential slower than this will converge. Any function slower than this will converge. So in the imaginary plane, this is s equals 1. Anything to this side that is slower than this exponential, they all will converge. That's a region of convergence for this. Okay. If you don't follow, don't bother a lot. I'm going with the meaning of what this function is and what that convergence is. Okay. And this e power t in this side, it becomes 0 here. So here we look at the S plane. So negative values actually looks like this. You know, it kind of decays in the right hand side. That is for positive t. For negative t, it actually explodes. So positive values are fine, starting from -1. Positive values are fine till -1. Till -1, at -1 it becomes a step. Okay, so this side is fine, and with that region of convergence of x of 1 real greater than 0, no, this is not correct. That is actually real less than 1. Region of convergence of x2 confined to the left of plane, no. Region of convergence confined to the right of plane, no. Okay, they both include the imaginary axis. Imaginary axis in that yellow region, imaginary axis is in this yellow region. This is correct. I'm going by what the meaning of convergence here plus what those functions mean. Without using a ROC range of areas, x of s exists. Yeah, where x of f exists, where it exists, I'm not doing it as a formula. Okay, I am actually going by the meaning of that formula. There is a difference between trying to recall the table, x of s table for e power minus t of t. The table, it says this is 1 by s plus 1 region of convergence. One can go by recall the table and do that. The table will not take you far. Okay, as far as this gate question is concerned, if you understand, in fact, if you follow the meaning of the explanation, again, Laplace calculation will take time. Okay, so if you understand the meaning that I gave for this symbols, strings, you can answer the gate question, point 1, and you can go much farther than what you could do with recalling the table. Okay, but anyways, and give this line of thought a time. Okay, see how far you could proceed. But anyways, let's move on. See, at the core of Laplace transform is a given function. How fast is it compared to an exponential? That's at the core of it. Okay, that question. Then looks like I have a video that I can put it without editing. Hey, I have this question. System described by the following differential equation. Initial conditions are not given. Hey, you need to know the. Technically, they should make it MTA. Someone, am I missing something? If you don't know what the initial conditions for the initial value of the output is there any way you could know the output, or the initial condition system? It's immaterial of the initial condition. That would be very surprising. At finite time, it's immaterial of the initial condition. I'd be surprised. Okay. But the quickest way to arrive at this is, okay, did anyone solve this? Find the particular integral complementary function, the thing. You don't know what the initial condition is. So, but you can know, I think I see where the examiner stands while setting this paper. If you quickly take Laplace transform, y of s is x of s is a step. So that is 1 over s. Okay. And this system that you have here is 0.01 s square plus 0.2 s plus 1. Does this term simplify? They have chosen a very peculiar form where this is essentially 0.1 s plus 1 whole square. If you take inverse Laplace transform, y of t, in fact, the 6th will remain here. Okay, and in fact, while taking the Laplace transform, I had to presume the initial conditions are 0. So y of t has a 6 u of t. Then there is 1 by 0.1 s. So can anyone see what the time constant here is? What is the value of tau? 0.1. Standard form is 1 by tau s plus 1. Okay, time constant is 0.1. It says in 5 time constants, the system decays to, so essentially the more terms here, roughly there is a e power minus t by tau kind of term. We don't know the initial conditions. Let's say there is a constant term here and plus another constant Ct, this is a quadratic, right? This is a repeated root, right? So Ct e power minus t by tau. Tau is very fast, 0.1. In 5 time constants, you have 99% of decay. E power minus 10t, right? T by tau, t by 0.1 is minus 10t. Can someone calculate e power minus 10? At t equal to 1, you have e power minus 10. What is the value of e power minus 10? Get calculator, e power minus 10. E raised to the power of minus 10. 10 power minus 5. So compared to this amplitude 6, you have a 10 power, depends on what these constants are for, but most realistic constants, again presuming 0, okay, some constant in initial condition in the order of 1, this term goes to 0, rounded off to 2 decimal places. This term is in the 5th decimal place. This term e power again minus 10 into 1, again that's in the 5th decimal place. So what you are left with is only this. Probably the examiner wanted you to look at the time constant. It is 0.1. So this is exponential decay involving e power minus 10t in 1 second. This will be essentially 0. This term will be 0. T times that again will be 0. Only this term is dominating. Only this term remains. See, answer is 6. Probably that's what they expected you to do. But for that, you have to certainly have to make this presumption. Okay, but the mindset of the committee is this. Okay, I step some inverse Laplace transform 1 by s plus a is e power minus at. Okay, so this is 1 by s plus 1 by 10, 1 by s plus 10. So that is e power minus 10t. Okay, but anyways, in fact, even if you had accounted for that 0.110 going here, this is still, these constants are in the order of 100. 10 power minus 5 is still, in 2 decimal places, it's still 0. Okay. Amar, Vignesh, I don't know any of your, Amar, did you follow this? This term is essentially 0 in 1 second. It dies down just like that. 0.1 second, it's almost decayed. 63% decayed. In 0.5 seconds, it's 99% decay. 1 second, this is like almost not there. Okay. A, cell viability. I'll do this really fast. You do 3 experiments, absorbance, when you have a chemical applied to the cells, when you have, you don't have the chemical applied, only the dye. I told you absorbance is epsilon L, epsilon L, I am putting that C. It depends on proportional to concentration plus C naught. Can you say that since it's unit step at T equal to 0, unit step is the input. Is there anything mentioned about the output? Unit step is the input. Output is the state is different. No, output is different. No, it can be, you can start from non-zero initial condition. There is nothing that tells you you have to start from 0. Okay, epsilon L C plus C naught. I mentioned this term during the class, right? It's a straight line with a possibly non-zero intercept. I'm just going to, okay, that C naught is important in this question. Okay, let's not, I'm going to club this L to this epsilon. Epsilon L, I'm going to call that as one coefficient. You have 3 conditions. The concentration is 0. 0.1 is C naught. Let's call this epsilon naught. If it's confusing, let's call this epsilon naught. See, this is again a question that is obfuscated. If I write down the equations, it will be fairly simple. Okay. This line states 0.1 is the constant is epsilon naught. Even if you don't have something, the die is going to absorb corresponds to 0.1. In the absence of the compound, there is no inhibition. Zero 0.8 equals epsilon L into C1. No inhibition. C1. First case. In the presence of the compound, 0.5 equals epsilon L into C2. Okay. What they are essentially asking you for is C1 minus C2 as a, originally there are 10,000 cells, inhibited 10,000 becomes 6,000, 5,000, something like that. What is the drop? What is that percentage? This is what they are asking. So given this, can you calculate this percentage C1 minus C2 by C1? And. This is, there is an epsilon naught here. There is a die there. There is die there. Yeah. Can you quickly find, you know, epsilon naught is 0.1. Can you quickly find out what this ratio is? I'll give you 30 seconds, a minute. Because one, this is a detail that I pointed out in the class. Do this. There is a mistake in the question. Epsilon naught is 0.1. So epsilon L C1 is 0.7. Epsilon L C2 is 0.4. You find 1 minus C2 by C1. C2 by C1 you can find it. 0.4 by 0.7. 1 minus that will be 0.3 by 0.7. I kind of gave you the answer. 0.3 by 0.7 into 100. How much is this? See, this is with, yeah. Okay, 42, approximately 42.9. A fairly easy question, no? They have put a confusing obfuscated, right? The gate thing. Point number 1. So this is what they are asking. So without inhibition, concentration is C1. With inhibition, concentration is C2. How much does it get inhibited? What factor does it get inhibited? Inhibited percentage is C1 minus C2 by C1. That's it. Where they are making a, so I highlighted about this detail. There is a constant here, don't forget it. The medium that the constant, the solute is in, solvent, that can observe something. But the detail that they are missing is, should this epsilon be same as this epsilon? One is with compound Q, another one is without compound Q. Does do you know that compound Q doesn't absorb anything? Is there sufficient information given for that? There isn't sufficient information. Need not be constant. That is, this epsilon, this can be epsilon L1, that can be epsilon L2. There is no way we can find that ratio. Okay, need not be constant. So the compound that you are putting in can interfere with the absorbance. That fact is not taken considered in this question. But anyways, again, they miss details like this when their focus is in obfuscation. Okay, so need not be a constant. Okay, but this is the answer key which I don't agree with, because there is a see, if this is a detail that you want to test the students with epsilon naught, hey, there is a constant there. It's not just a straight line. It's a straight line with a non-zero intercept. You have to be careful about the constant. Does the constant remain a constant when you add the compound or not? Okay, the detail. I mean, there is a mistake. Okay, 448. Hey, high school question. I'll write the strategy, man. Find T to hit ground. This is V, Vx, Vy. It goes up, comes down, travels a distance of -2. What is the time taken for that? Probably that's a quadratic equation. You can find the time corresponding to that positive time or the longer time. And then 2. This is Pxt is 6. Okay. 2 steps you can do this. This is high school. How is this question related to BME? Probably they ran out of time, or like one of the committee member did not submit the promised number of questions. The person had to give 65 questions, so they inserted one question. Okay, take. Is this biomechanics? Mechanics, high school mechanics, not biomechanics. Okay. So you could go do solve this for completion. I'll just put that number. Range 6.3 to 6.9. Okay. We still have 10 more minutes. This is after the initial 10-15 minute conversation that we have. Roughly 2.5 hours, 2.5 hours into the exam, we are done with the question paper. And at this time, I'm not done. Ideally, if I am giving the GATE exam, I am checking some of the mistakes that I have made. I would have caught it. Quickly double check my rough note, this note, this note, this note, right? I'm really double checking 10-15 minutes. MSQs, all MSQs answered, all NATs answered. So probably you know, right? The first pass we were here, second pass, I left one question. I did not have the time, or I couldn't read the question. I know it's slightly, there might be a simple formula, but from first principles, answer is slightly farther away. So that's why I said with a little bit of recall, some basic formula. Also, you know which formula that I am referring to in this question paper, in this range. Fairly easy. I hope this walkthrough was important. Partly, this is like hand holding, time management. How do you manage easy question, hard question? How do you fall for a trap, not fall for a trap? Careful. Doing it along with me should have given you more confidence. Should have given you confidence, certainly more confidence. And we can discuss about more and more technicalities, mistakes, issue with the key, this, that, and all that, related concept and all that. But at this stage, it might start getting confusing. So it would be a good point to stop, right? Unless there are any pressing issues, this would be a good time to stop, right? So my wish, see, whatever I did it, this is 4 years of GATE preparation, not formula recall, this, that, and all that. 4 years of teaching for GATE biomedical examination, right? Whatever number that I am referring to. And what I am really hoping for is some of you get in this 70 plus, 75 plus year. Yeah, BM is there only for 4 years, right? Has never made a BM paper. So most of the diagnostic, subject-wise diagnostic questions that I have given are from IAC question papers, because those questions are conceptually harder. So expect it to be similar. On an average, it won't be harder. On an average, the questions you are given in subject-wise diagnostics will be harder. The questions I set are hard. Yeah, there is this impression that gate questions are hard. No, questions that I set are very hard. Okay, there will be expect a handful of questions at the same level of difficulty. Most questions will be moderate or easy, even for an IIC paper, because the questions that I gave you are from most of them are from IIC papers. I have done 20-30 years of past year gate this competitive exam papers specifically focused on IACs, and I have given them because those questions are good. Okay, so you are trained well, nothing to really worry about it there. So this is my real wish. I hope more than single digits, all India rank and all that. I hope all of you learn biomedical. All of you learn things about how to approach challenges. I hope many of you acquired a lot of good characteristics spending some time with me in this program. Okay, and my simple wish is that some of you get here. Okay, more than single digit ranks. You put a very good show that you're above first class, above 60% roughly, 70-75%. That will be a very good show that you know the subject. Okay, and I hope that happens. And I am very grateful for this journey with you. There will be one more class. We will briefly meet probably next Saturday or something like that, but I am very grateful for this. I feel very fortunate to help, teach, guide, mentor very young, energetic, enthusiastic students like you all. Okay, not all. Most people don't get this opportunity. Even most teachers don't get this opportunity. In that sense, I feel very fortunate, and I always feel blessed. Okay, be confident, and yeah, all the amount of the nice things that you have done will eventually reflect. Okay, so with that message, let's just meet Saturday briefly for a quick chat, but I think this is a good time to stop. Okay, so have a good one, and I'll send you details in the group chat. Okay, let's stop this. Where is stop sharing? Stop recording. Sure. Okay. Yeah, you all have a wonderful time. All the best. We'll briefly meet once again. Okay, and then I'll see you again. Let's briefly meet Saturday, and then we're kind of done for this year's